Well, warm welcome to today's talk. It's Thursday, the 30th of December. Now, we like to keep an eye on the evidence as much as we can on this channel and base what we're saying on science. So this is just a short report on this paper from South Africa because it's remarkably encouraging. So this is the paper here. Now, you will see that it's a preprint, so it hasn't been peer-reviewed yet, but it is by the most reputable institutions in South Africa, and I've read it, and it's really good news because it's showing that despite the antibody response being reduced to Omicron variant, the T cell response and the B cell response, these longer lived memory cell responses, is looking good and looking encouraging. And this would explain why there's been relatively few hospitalizations in South Africa and very, very much fewer deaths, very many fewer deaths in South Africa compared to previous waves. So let's look at that now because it really is a good news science study. Now, obviously it's not peer reviewed. Now, I've read it and it looks pretty good to me. What I can't comment on is the analytical experimental techniques where they're actually looking at these B and T cells in detail because I don't pretend to understand that in detail. And they don't record it all in the paper anyway. But so as long as we take their word for that bit, the rest of it looks pretty good. And I'm confident this will be peer reviewed in pretty short order. It'll be fast tracked, I would imagine. So SARS coronavirus 2 spike T cell response. So this is the spike protein, and this is the T cell response. These T lymphocytes that are like the second line of the immune system after the antibodies, induced upon vaccination or infection. Now, the good news about this is you get a good T cell response after vaccination and or natural infection. So this is working well against natural infection, which I did kind of suspect it would be because there's lots and lots of different proteins in the natural virus. What I was more concerned about is because the vaccines that we're giving only work against the spike protein, we might get less of a response. Well, we do get a less response, but not much of a less response. It's still a pretty encouraging response. So my anxiety on that is now quite reduced, actually. Now, lots of reputable places in South Africa, Institute of Infectious Diseases and Molecular Medicine, University of Cape Town, for example, but basically every university in South Africa that's worth mentioning. So I think we can rely on the integrity of this data. And it's not from the popular press; it's directly from the site. The mainstream media and the popular press has been really getting on my nerves lately, actually. It seems to be very alarmist and designed to entertain. And, I assure you, I will make no attempt to entertain. If I do entertain, it's entirely inadvertent. It's not meant. This is to give understanding that we want to do this, not to entertain at all. SARS coronavirus 2 Omicron variant has multiple spike protein mutations. We know this. In fact, there's about 32 of them. So it really is quite different to the wild type ones. These contribute to escape from the neutralizing antibody response, reducing vaccine protection from infection. So the neutralizing antibody response is reduced. Now, the antibodies are the immunoglobulins. Now, what it means here by neutralizing antibodies is if we imagine this virus with these infinite spikes on it that we know all too well now. And of course, it's these spike proteins that normally fit into the body cells to get the virus. That would be the body cell there, roughly drawn to some kind of scale. It's a huge body cell being infected by this tiny virus, that ACE2 receptor that we now know well. So that has to fit, that bit there, the virus spike has to fit into there. But what the neutralizing antibodies do is they stick onto there and they make a big clump there like that, literally a clump. They literally clump onto it, and what that means is that can no longer fit into there, so the virus is neutralized in that it can't cause infection. Well, we know that this antibody response is reduced, we know that, but in this study they assessed the ability of T cells to react with Omicron spike. Now, when we look at it, the numbers don't look that big, but of course this involves really quite detailed science on the cells themselves. So actually the numbers are more significant than they would be in a comparative epidemiological type study. So the numbers actually aren't bad given the high level of analysis you need to do to make sense of this this experiment. So in participants who were vaccinated with, this is the AD26-CoV-2.S, in other words, the Janssen Johnson & Johnson vaccine. So participants vaccinated with that, there was 20 of those. So immediately you can see that forms one group. And the good news is this has been working well in South Africa. And the Johnson & Johnson vaccine has been working particularly well. If a second dose is given after 2 doses, it has been working really very well. So that's one group there. The next group was those vaccinated with the Pfizer, 15 of those. So you can see we've got one group of comparison there, we've got a second group of comparison there, and we've also got another group of people that were unvaccinated but were convalescent for COVID-19. In other words, they've been exposed to the natural infection. So we had a third group there. And as we said, detailed scientific work was done on their lymphocytes, their small lymphocytes, their B and their T cells, with these 3 group comparisons. So quite a nice study, really. SARS-CoV-2 specific T cells play a key role in modulating COVID-19 severity and providing protective immunity. So that's the background science. So there's these 2 levels, well, there's multiple levels, but the ones that I used to teach my students about, the 2 basic levels. The first one, of course, is the antibody response. The second one is these B and T cell responses. So basically these B and T cells, these are the small lymphocytes, and it's the B cells that actually produce the antibodies, produce the immunoglobulins. And it's the T cell, there's various types of T cells. Some T cells help or stimulate the B cells to make the antibodies. Other T cells, the T cytotoxic cells, will kill virally infected cells directly. So there's different types of them, and they're all absolutely brilliant, well, totally necessary for second line immunity. And this actually could explain why people are still getting infected with Omicron, because the first line antibody response is not working. But they're not getting sick, at least they are in very much smaller numbers, we believe, or I think we can say that now. They're getting sick in very much smaller numbers because the T cell response is kicking in and stopping people getting sick. So it's remarkably good news study. So the results, 78% of the CD4 and CD8 T cell response to spike was maintained across study groups. So that's the spike protein, that's the antigen that the virus uses to get into the cells. Now the CD4, these are the T helper cells, and the CD8, these are the T cytotoxic killer cells. So these are the 2 sorts of small lymphocytes, the T cells rather, the CD4s, and the CD4s stimulate the B cells, and it's the B cells that actually produce the antibodies, or the immunoglobulins. So ideally, of course, you've got both. And the CD8, the cytotoxic killer cells, that they will directly kill the virally infected cells. So that's the virally infected cell with the viral particles in. This lymphocyte will come along. It will drop noxious chemicals. So that's the CD8, the cytotoxic cell, will drop noxious chemicals on the cell and kill the whole cell. The cell can be replaced by mitosis from adjacent healthy cells, but the viruses are all killed. This is why it's so important. The magnitude of Omicron cross-reactivity in T cells was similar to that of Beta and Delta variants. So, of course, remember that the vaccines were actually developed for the original wild-type variant. So what this is saying is that the cross-reactivity between the wild-type might be reduced a bit, but between the Johnson & Johnson, the Pfizer, and the convalescent patients, there was cross-reactivity. It was maintained. So we've got this phenomena called cross-reactivity. Omicron cross-reactive T cells was similar to that of the Beta and the Delta variants. So pretty well Omicron being killed just as effectively as the Beta and the Delta variants, this cross-reactivity. Now, I've told you this story before, perhaps, but Edward Jenner, who was the first person to generate a vaccine, essentially, it was actually an inoculation in those days, but he gave a boy called James Phipps, he gave him some pus of cowpox in his arm. scraped it into his arm. And that cowpox pus stimulated an immune response in James to cowpox, but there was cross-reactivity with smallpox. So James was also immune to smallpox after that. This cross-reactivity, because they're similar enough, the immune system can react to them not quite 100% as good, but pretty well as good, and we get this phenomena called cross-reactivity. This is the problem when we have a genetic shift. So if a completely new virus comes along and we haven't been infected with anything which looks a little bit like it, then we can get really bad infections, as per the 1918-19 pandemic, where there's a completely new type of virus. Whereas most years we get colds, of course, we keep getting colds. That's because the cold virus doesn't usually undergo this genetic shift. It just drifts a little bit. There's a few mutations. And we'll get a cold, but we don't get a cold as bad as we could do because we've got some cross-reactivity from previous viruses. So it's saying that is maintained, which of course is exactly what we want. Then some direct quotes from the authors. These results demonstrate that despite Omicron's extensive mutations and reduced susceptibility to neutralizing antibodies, which of course we now accept, the majority of the T cell response, induced by vaccine or natural infection, cross-recognise the variant. I mean, really, this is just an absolutely brilliant result. We really couldn't have hoped for better science than this. This is excellent. Well-preserved T cell immunity to Omicron is likely to contribute to protection from severe COVID-19. Excellent. Supporting earlier clinical observations from South Africa. So this is what we saw clinically. We saw in South Africa this is what was happening, which is good. Now we've got the science which supports that. And when the clinical epidemiology on the ground and the laboratory and the bench, the science in the laboratory and the bench support each other, then that is excellent. That's exactly what we want. They are both in agreement. And then the authors do give a bit of further explanation just to spell it out a bit. So we'll just do this before we finish. The limited effect of Omicron's mutations on the T cell response suggests that vaccination or prior infection may still provide substantial protection from severe disease. Brilliant. Indeed, South Africa's reported a lower risk of hospitalisation and severe disease compared to the previous Delta wave. Big time it has, significantly so. But here we have the science to explain it. Cross-reactive T-cell response acquired through vaccination or infection may contribute to these apparently milder outcomes for Omicron. So again, they're being very cautious and scientific here, but I would think that is highly likely. The resilience of the T-cell response demonstrated here also bodes well in the event that more highly mutated variants emerge further. In other words, the T cells are responding to not a small part of the spike protein, but to the whole spike protein, the hundreds of amino acids on the spike protein. It's responding to them all. Another reason I'm optimistic is the probability of another mutation coming along that outcompetes Omicron anytime soon probably isn't that high, because Omicron is so infectious. It'd be really hard to imagine a variant more infectious than that, which would outcompete it. The only one that could potentially outcompete it is one where there is very, very comprehensive immune escape, but that's exactly what this study is saying will probably not happen. So that took away kind of the final anxiety I had that the Omicron might not be the final variant, at least for a period of time, because I don't think anything's going to outcompete the Omicron in terms of sheer infectivity. This is saying that if another variant does arrive, it probably won't have immune escape against the T cell response. Isn't the immune system wonderful? Thank you very much for watching.